This is the second of two video lessons on solving trig equations. In the first lesson we were working with the sine function and degree mode. In this lesson we'll look at some examples involving the cosine and tangent functions, and let's work with radian mode. The first example is an equation with cosine that we can factor. And even if we can't factor a quadratic, we can always use the quadratic formula. In this case we shouldn't need to, as I've rigged this one up to factor. Since 2 is prime, it makes less choices for us. And I think if we put a 1 here and a 2 here and then choose our signs appropriately, we're going to want to end up with negative 3 cosines. Let's see if we put a negative here and a plus there. If we FOIL that out, we'll see that we have 2 cosine squared x minus 3 cosine x minus 2 equals 0. Now that we've got our equation or left side factored, we can look at each equation individually. So setting each of these equal to 0 gives us two separate equations. 2 cosine x plus 1 equals 0, or cosine x minus 2 equals 0. And now we proceed to solve each of these linear equations, which are simpler, linear in cosine. Okay, isolating cosine on the left equation gives us cosine x is negative 1/2, and on the right cosine x equals 2. Let's dispense with the right-hand equation first. We know that the cosine function has a range of -1 to 1. There are no angles or real numbers for which the cosine is equal to 2. So right away we can put no solution for this part of the problem. And for cosine x equals negative 1/2, our reference angle, where cosine is 1/2, would be 60 degrees or pi over 3. And since our cosine is negative, that puts us in quadrants 2 and 3. So therefore x would equal 2 pi over 3 for the quadrant 2 solution, or x is 4 pi over 3 for the third quadrant angle. And to get all solutions, we would want to add a 2 pi times, I'll often use n, where n is an integer. So the full solution, the infinitely many solutions which solve our original equation, are given here, where n is 0, plus or minus 1, plus or minus 2, and so on. Shorthand way of writing that is you say n is an element of the integers. For our second example, let's work with an approximation, a problem where we need an approximation. So something simple like cosine of x is equal to 0.4545. So as an initial step, we'll look at the cosine inverse function evaluated at 0.4545. Since we're going to work in radian mode, we'll grab our calculator, put it in radian mode, and we round. I tend to round to 4 decimal places, and rounding to 4 decimal places is 1.0990. Now with these problems we need to be careful, because we know the cosine function reaches this value, and we can see that answer is in quadrant 1. But we also have a positive cosine value in quadrant 4. So we want some symmetry, use some symmetry here to get this bottom angle that I'm drawing. So the top one here is about 1.0990. Taking the original cosine inverse of 0.4545 and subtracting that from 2 pi would give us the larger angle, which would work out to 5.1842. Well, our work is pretty much done. We just need to summarize our solution. So as before, we would write out our solution as an approximation. It would be 1.0990 plus 2 pi n, or x is approximately 5.1842 plus 2 pi n. Whoops. Where n is any integer. And the short way to write that is like that. For our final example, let's work with the tangent function. So let's suppose now that we've got tangent of x equals 0.1234. And let's find all solutions using radian mode. To start off with, we'll use our calculator to approximate the angle whose tangent is 0.1234. And from my calculator, rounding to 4 decimal places, I have 0.1228. Okay, so here's a picture of the angle whose tangent is about 0.1234. Now the period of tangent is pi, or 180 degrees. The other angle we're going to get that has that same tangent value would be 180 degrees from this one, so down in quadrant 3. So we could find that angle, or easier would just be to say, okay, x is approximately 0.1228 plus pi times n. And that's it. That'll cover all the solutions, since from our picture we can see each time we go 180 degrees or pi in either direction, we're going to pick up either one of those two angles as a coterminal angles. Okay, so our solution is given here. So when working with any of the trig functions and solving these equations, once you've established and needed to use an inverse trig function to establish an approximation, be mindful that that calculator will only give you one of infinitely many solutions, and depending on the period of the function, you'll need to adjust by either adding pi n or 2 pi n. Hope this helps. Thanks for watching.